My name is Laila binti Rawami and my metric number is A174805. So I will present about the introduction of this project. So normalization is a part of the database design process. Thus it cannot be separate the normalization process from the ER modeling process. The two techniques is being used, which is ERD to provide the big picture of organization data requirements and operation. This is created through an iterative process that involves identifying relevant entities, attributes, and relationships. Normalization procedure focus on characteristics of specific entity within the ERD. Besides, normalization theory draws heavily on the theory of functional dependency. Each normal form in normalization involves a set of dependency properties that a schema must satisfy and gives guarantee about the update anomalies. This means the higher normal form have less redundancy and as a result fewer update problems.
This table lists down all the attributes from our UKM folio ER diagram. If there are missing one attribute in the table, our ERD is not valid. Based on the ER diagram, the first one we look at is the student one. Okay, the student one. There's a metric number, student name, and student password. So in the table, we have student name, student metric, and student password. Okay, for the lecturer, we have a lecturer metric number, lecturer names, and lecturer password. And in the table, we also put lecturer name, lecturer metric number, and lecturer password. Okay, for the course, they have course ID, student metric number, lecturer metric number, course name, student program, and student faculty. Because there's already have student metric number and lecturer metric number in the table, we just put the course ID, course name, program, and faculty. For the general, there has course ID and announcement. Because course ID already in the table, we just add the announcement. For the course material, there's course ID, notes, task, project, and tutorial. So we just add the notes, task, project, and tutorial. For the participant, there's course ID and student name in the course because the course ID already in the table and student name in the course in at the student name. So the participant is complete. And the last one is grade. The grade has course ID and report. So we add the report and the grade for each student.
So for the logical database design, we use the ERD and ERM.
The ERD shows that at least one student take at least one course and at least one lecturer teach at least one course. The course is not necessary to have participant, grade and so on because it depends on the lecturer. The primary key is student metric number, which is we can take the whole information about student. Same goes to the lecturer metric number and course ID.
Functional dependency describes relationship between attributes.
Number 1, student metric number determines student name, student PW, course ID, course name, program, faculty is a partial FD. Number 2, lecturer metric number determine lecturer name is a transitive FD. Number 3, course ID determine course name, program, faculty, lecturer metric number, lecturer name, lecturer PW is a partial FD. Number 4, student metric number, course ID determine program is the primary key.
A normalized table, which is known as UNF.
UNF is a table that contains one or more repeating groups. Based on the table, the faculty FTSM and FPEN are repeating group because has two students in same faculty respectively, so we must combine them in one row and column. 1 and F is a relation which the intersection of each row and column contains one and only one value. So, for the 1 and F, we use the faculty relation. Based on the table, FTSM and FPEN are repeating group, so we must separate them into each row and column.
Okay, so I will explain about the process. So why we do this process? Because we want to remove the duplicated data, and then we want to eliminate the useless data. So let's proceed. So for the first process, UNF to 1NF, so in this table should have the single value attribute. So and then it's must have the Unix name. So all of the data must be different. Okay, and then okay, that's it. So for the second process is 1NF to 2NF. So all attribute depends on the key. So depends on the key. So we have here the three tables. So all of each of this table depends on the key. So for the first one, student table, so we have the student name, student matrix number, and the password. So depends on the metric number. And then for the student programs, content of student matrix number, course ID, program, and faculty. So it depends on the course ID. And then for the course detail, it contain the faculty, lecturer name, lecturer matric number, lecturer password, course ID, and then it depends on the course ID. Okay. Okay, let's proceed to the last process 2NF to 3NF. So here we had the four tables. So in this process, all field can be determined only by the key in the table or no other columns. So we have to put aside the transitive. So here for the first table is student details, so student name, student matric number, and the password. Secondly is student course, faculty, student matric number, course ID, and the program. And the third one is about the course details. So faculty, lecturer name, lecturer matric number, lecturer password, course ID, course name, and the program. And then the lecturer name, lecturer matric number, and the lecturer password. So here is it. So
In conclusion, normalization is the branch of relational theory that provides design insight. It is determined how much redundancy exists in a table. It also could be characterized the level of redundancy in a relational schema. Besides, provide mechanism for transforming schema in order to remove redundancy. Thank you.